So now we want to talk about the different types of wireless LANs. So the first type of wireless LAN topology is called the Independent Basic Service Set, the IBSS. This one here does not involve an access point. If the basic service set does not involve an access point, what that means is it has no connectivity to the wired network. So in this environment, you would have clients such as PCs, tablets, smartphones that use their Wi-Fi radio capabilities to communicate directly with one another. You'd normally put these devices in sort of a range somewhere between 10 and 70 feet of each other, and they'll be able to communicate and share information between each other. This is sometimes called an ad hoc network. You have to be a little bit careful with ad hoc mode, especially if you're at a public place like an airport. If you see free Wi-Fi and it's actually in an ad hoc as opposed to an infrastructure mode, quite often it can actually be someone trying to get into your computer. So you should try to avoid that if you can. Now, the infrastructure basic service set, normally just referred to as the basic service set, is the one that you would typically deploy in your home, typically deploy in the enterprise environment, and that involves an access point, and the clients communicate to the access point, and the access point provides connectivity to the wired network. So a wireless client would connect to the access point and then through to the wired network out to the internet or the corporate network. A basic service set has an SSID, and it's possible to set up an access point with more than one SSID. If you have multiple basic service sets and they have the same SSID and that there's a network between them, so the access points can communicate between each other over what's just commonly referred to as the distribution system, then this is referred to as an extended service set. An extended service set could be physically in one building. A company like AT&T here in the US has multiple basic service sets at McDonald's and Starbucks and at the airport, etc. But it has one SSID, so it looks like one extended service set. So an extended service set does not require the BSSs to be physically located together. They could be co-located or they could be physically separate. And it's very important to understand the concept of an extended service set, because when you look at roaming at a layer 2, then you can do that within an ESS. Now, mesh networking is a very important configuration to be considered, and the Cisco mesh networking enables 2 or more access points to communicate with each other using the wireless LAN 802.11 technology. Now, the way this typically works is that the mesh points, the mesh access points, will communicate with each other using the 5 gigahertz band, and then clients will communicate to the mesh access point using the 2.4 gigahertz band. So in this picture, I'm showing the links between the mesh access points, but those mesh access points, if they're dual mode access points, could also be communicating with clients. Now, a mesh environment, 2 typical scenarios where you see those being deployed. One would be somewhere like a factory or a warehouse where you want to get coverage in a very large area, but you just don't have the ability to pull an Ethernet cable to the access point, and so you get the access points to talk to each other wirelessly. The other scenario would be in an outdoor environment, and this is where you'd see mesh access points being deployed on streetlights, and they're deployed on the streetlight, and again the streetlights mesh access points communicate on the 5 gigahertz band, and you're down at the street level with your laptop or tablet or smartphone, and you'll communicate with the mesh access point using the 2.4 gigahertz band. Now, when you form a mesh network with the Cisco technology, you have mesh access points like we've talked about, and then you'll have root access points, and you can see that on the top of this diagram here. And the root access point is the one that connects to the wired network. Now, you have to be careful when you form mesh networks not to have too many hops, because the more hops you have, the more latency that you're going to experience, which is particularly important if you're going to do any voice or real-time video traffic. Now, the mesh protocol of how these mesh access points talk to each other, so they're talking over the 802.11 network, but the higher layer protocol that decides, how to connect and when to send data, that one is called the Adaptive Wireless Path Protocol. So it's a Cisco proprietary that determines which path frames will take from various mesh points if they're going, let's say, from mesh access point 9 to the wired network. Does it go through mesh access point 8 or 5 or 6? So what route does it take? That is determined by the Adaptive Wireless Path Protocol. So a workgroup bridge. This is a really interesting scenario, and this is when you want to connect some wired devices, so maybe some wired Ethernet clients, some desktops that you want to connect to the network, and you're going to use the access point to provide that connectivity. And so you see here that you're wired in from the clients through the switch or the hub into the actual wireless access point, and that wireless access point is configured as a workgroup bridge, and then that will wirelessly connect to a root access point, and that root access point is connecting both to the workgroup bridge as well as other wireless clients. So from the root access point's perspective, that workgroup bridge looks and feels just like a wireless client. The thing that's important to know about the workgroup bridge is that it only connects wired clients. The access point that's configured as a workgroup bridge will not support the connectivity of wireless clients, so you can't connect to it. The next network topology that we should be looking at here is the wireless bridge. Now, when you think of a bridge in a wired network, you think of it as connecting two wired LANs together, and they operate at the MAC data link layer, which means they don't have any IP routing capabilities. And a wireless bridge is the same thing, except that you're connecting it via a radio link. So in this example, I've got my access point set up as a remote bridge, and I've got two remote bridges talking to each other, and they're talking using the 802.11 radio technology. And so I need to configure both access points as a bridge. And then on the other side of the bridge, then it can connect the wired network. So this would be a great example, for instance, if I had a wireless LAN in one building and a wireless LAN in another building, and I didn't want to connect the buildings using a wire, then I can use 802.11 as a bridging protocol to connect those two wired LANs together. Now in this illustration I'm showing it as a point-to-point connection, but you can have it as a point-to-point or a point-to-multi-point connection. The other thing you should just be aware of when you're configuring wireless bridges is there is a difference between a root device and a non-root device. In this picture I've got two root devices in the sense that they're both connected to a wired network. A non-root device would be able to communicate wirelessly to another bridge, but it does not have a wired connection. I hope you enjoyed this module.